So I'd like to first I'd like to everyone to check that your tag on One Academy is data science. So I will share my screen and explain this to you. So you can click on your icon and see whether your tag here is data science. And I want everyone to set your tag as data science because it can be easier for us to search for the node that you have proposed. And if you find that your tag is not data science, you can change it to data science. And if you have already proposed some nodes, please check that the tag of the nodes is data science. And if not, you can please also change the tag of the node to data science. And for the search, when you are search, you can choose data science here just by click here and have it chosen. So you can search for the nodes. So is there any question about this part? Okay, and another thing is that every time you create new nodes, please check that it haven't been covered in our map, since we don't want duplicate informations to be covered in our map. And then I will, yes, I'd like to ask everyone that whether you have created your first node. So, Aryan, are you here?
Yeah, I'm here.
So you have already created your first node, or you are still learning something?
No, I haven't created yet.
Okay, got it. So I think Jiayun and Jing has already, and Meta, Nikis. Robin, have you created your first node?
Yes.
Okay. So, Aryan, after today's presentation, could you please stay with me on our meeting? And I will give you a quick tutorial to help you create a first node.
Yeah, sure.
Okay, thanks. Then I will move on to the next part. I will introduce our detailed research plan to you, and after that, we can move on to the presentation part today. So, you can also find it under the files of our private channel. So as you can see, here is our detailed research plan, and we plan to finish the Coursera specialization as well as the textbook before the end of October. And after that, our big team will be dismissed, and the top contributors in the learning period will form a small research group, and we will working on concrete paper idea. Yes, and from November to mid-December, we will summarize a significant number of research papers. And from mid-December to mid-February, we will literally design, develop, and test our models. And after that, we will author the paper and submit to top conference. And note that this timetable just gives a general idea of what needs to be done around each time period. And adjustments may be made in the future depending on how effectively the research team works on the project. And each person's contribution is assessed by considering the quality and quantity of the presentations, of his or her proposed notes. And I'd like also, I have a list of the concrete research ideas. Eamon has already proposed a research idea. And if any of you during the learning period, you come up with a good idea that you think we may work on in the future, you can add it to the list here. Is there any questions? All right. So here's a comment is that every week I will create a post in our private channel, and I want anyone, if you'd like to give a presentation in this week, please comment on this post with the content you'd like to present. And as soon as possible, if you have planned to present, I'd like you to first put your comment here, since because I don't want the case happen if you are preparing the content that someone else is already prepared. So please comment with the topic you are working on and plan to present in the week meeting under the post here. And also, a number of people told me that they find it difficult to find a topic to give presentations. So you can see here in the sheet 2 of our records of presentations, I have list some potential topics that I think they are meaningful to be presented to our team. So you can see here. And if you'd like to start with one of the topics listed here, please write your name and the topic in column A and B, and delete it from column G and H here. So each of these topics just cover about 2 to 3 videos in the Coursera specialization, and it will take less than 20 minutes for you to learn through these videos, and then you can summarize what you have learned on our platform and then give us a presentation. Is there any questions? So here, I'd like everyone to put their name and the topic they are now working on here. And they are not, you don't have to present it in the nearest meeting if you put your name and topic in progress here. It's just to take the record of what everyone is working on now. So Meta, maybe we can start with you. So what is the topic you are working on now? Hi Meta, are you there? Okay.
I think, can I just go first if we're gonna be doing this in order? I was wondering, like, if we're gonna be putting them down.
Hey.
Like, oh, sorry.
Sorry, guys. I'm sorry. I was away from the computer for a moment. Yeah, I'm working on like ResNets, but that's in the CNN course.
Okay, so that is ResNet, right?
Yeah, and I could also do like softmax. If that's
okay. You can update it by yourself in our sheet.
Great. Yeah, so yeah, I can do that. That's what I was planning to do, but I didn't know if you wanted to like go over it right now.
Okay. And that works for everyone. You don't have to choose from the list I provide.
Okay.
I encourage everyone to think of their own topics. But if you feel difficult in this part, you can choose from the topic I provide. Okay. So I know that Aryan is also prepared for the presentation, right?
No, I haven't prepared for the presentation.
Okay. So do you have, since you told me that you plan to present in
Oh,
our
wait, that
next
was.
meeting.
Oh, wait, I don't know. Wait, sorry.
Okay, so I hope that you can update your progress here after our today's meeting. Okay.
Yeah, I'll do that.
Okay, thanks. So I think that's all for my part, and we will move on to our presentation today. Nikis?
Yep, I'll go start. So today I'll be presenting. Wait, hold up. Let me just get this. Academy. Yeah, so today I'll be presenting on regularization, but I think before we talk about regularization, it's important to kind of discuss bias and variance a little bit. So, like, one reason that people like manipulate the hyperparameters is because, okay, sometimes when you're doing your model, it'll like overfit or underfit, and to get the best fit, you'll kind of adjust them so it's right. And so, this two things that like come out of this are bias and variance. So bias is basically the difference between like the average prediction of the model and like the model that we're trying to predict, whereas variance is the like how much it kind of learns from the past data, as far as I can tell. And so like models with a high bias will be underfitted a lot, and so they'll be like oversimplified, whereas high variance ones won't really be able to be generalized as well, and they'll be overfitted. And so it's kind of like a scale between like bias and variance, underfitting and overfitting. And so by finagling with the different hyperparameters, you can go and get the bias variance trade-off to where you want it to be. Though, yeah. And so one technique, if your model is overfitting, it means that the variance is too high. And so one technique you can use to fix this is called regularization, which is basically where you like add a oh, I guess it didn't save my change, but anyways, so one way you can fix this is by regularization, which just when you basically what it does is when you're training the model, it'll make the model simpler while you're training it, which helps reduce overfitting and thus reduces the variance. So there's like three main ways that people use that are like well known. Two are called L1 and L2 regularization, which involve changing the cost function and by adding a coefficient to it to reduce the weight, to have a penalty on the weights of the in the matrix. And then another one called dropout regularization, where like take a you set a probability, and for every iteration of training you do, it'll it'll based on the probability take random nodes from the model out, and so it'll help make this model simpler that way. So the first one that I'll be covering today is L2 regularization. It's also known as weight decay, and so it adds a term to the cost function, which is equal to the sum of the squared weight values in the weight matrix, and you weight that in the function by lambda over 2m. And lambda is called the regularization rate, and that's kind of how much the model itself is affected by your regularization. And so that's another hyperparameter you can adjust to get the model the way you want it. And then, so you can see here, it's just the cost function, which is like the normal cost function, plus lambda over 2m times sigma weights, the sum of the weights squared. And then L1 regularization is similar to L2 regularization, but instead of using the square of the sums of the weights, you'll use the absolute value instead, is generally not used as much because whereas the sum of the squares will encourage it to like approach 0 but not actually reach 0, the L1 regulation will make them hit 0, which leads to a compression of the model and not necessarily always what you want. And then the last one that I'll be covering today is dropout regularization, which is pretty different from the other two. So whereas L2 and L1 regularization affected the cost functions, dropout regulation affects the whole like model itself. So the way you do it is you assign a probability P, and so the probability P governs how much like a given node in the model is the probability is going to be turned off during a current iteration of training. And so like every iteration you do, like some nodes will be randomly turned off and others will be keeping on. And so it'll make the model simpler, which will help with variance concerns while training, but you'll still gain the benefits of a larger model during testing. And it'll also make it a bit more robust because no one node will have excess influence on the model itself. And so you can show that it's a similar effect to L2 regularization. And it's generally used the most out of all three of these, though oftentimes people will combine like L2 and dropout because it not only accomplishes the goals of penalizing complexity, it also applies some robustness to the model. And yeah, those are the nodes that I wrote today. Does anyone have any questions?
Okay, I have a comment is that, Nikis, could you please search for the node underfitting and overfitting?
All right. Oh.
Yes. Could you please link, link the bias and variance to this node, since I think they are related.
Yeah, that's definitely true. I'll go link them together.
Okay. You can do this part after your presentation. Yeah. Okay.
Okay.
Is there any other questions? Okay. Thanks, Nikis, for your presentation on regularization. So maybe we can move on to Jiayun. Jiayun.
Hi.
Yeah.
Sorry, I just mute myself. Okay. So let me present my screen. Okay. So this is So I want to talk a little bit about, like, this is not in the video, but I want to talk a little. Wait, sorry, Okay. So I want to talk about, like, I believe in the video of the logistic regression, like that the instructor in the video, he just like assumed that, he just assumed that, okay, how our hypothesis function will be the sigmoid function. And I want to talk a little bit about why we are choosing a sigmoid function and why, like, we are choosing the reasoning behind choosing the hypothesis for like different distribution. So that actually based on the generalized linear model. Generalized linear model is basically, I searched this online, but it's like saying that a flexible generalization of ordinary regression that allows for a responsive variables that have error distribution model other than a normal distribution. So basically, this model is suitable for actually not just linear regression. It's suitable for logistic regression, linear regression, and like linear regression is from the Gaussian distribution, and logistic regression is from the Bernoulli distribution, and is also suitable for the softmax. Okay, so what exactly, the definition is a little bit hard to understand, so we can dive in and see what exactly is the GLM. So the first thing I want to introduce here is something called exponential family. Basically, the exponential family is that if we have a class of distribution, like if we have a Poisson distribution, or if we have a Gaussian or Bernoulli distribution, if we write out the distribution formula, and that formula can be expressed in this way, then we say that distribution is in the exponential family. We can later see how useful if this distribution is in the exponential family. But for now, we can say that that distribution is in the exponential family. Okay, so let me further explain this. So, like if you have a Gaussian distribution, then will have a Gaussian formula, and you will see that by cleverly choose B, eta, and A, you can actually express that formula in this form. So therefore, we can say the Gaussian distribution is in the exponential family. You can do the same thing for you can do the same thing for I think Poisson and Bernoulli. So something to notice here is eta is called natural parameter, ty is sufficient statistic, and eta is log partition function. The most important thing is here is we usually choose ty equals to y. So we usually only need to cleverly choose b, eta, and a so that we can transform a distribution into this format. So let's see an example. So, okay. So for the logistic regression, for example, we know that logistic regression is used to solve the problem of binary classification. So for binary classification, you will define there will only be two cases, which when one is y equals to 1, one is y equals to 0. So let's say that the probability of y equals to 1 is phi, and probability of y equals to 0 is 1 minus phi. This falls to the Bernoulli distribution. And we can write this the probability of y based on this formula, because you can see that if y equals to, the probability of y equals to 1 is phi to the 1, 1 minus phi to 0, so basically phi. And then probability of y equals to 0 is phi 0, 1 minus phi, 1 minus 0, so basically 1 minus phi. So we can write the probability of y in this way. And then you can do some math. You can take the exponential log, and then you can transform the probability from here to here. And from here, you can choose TYA eta BY like this. And then if you replace TYA eta BY in this formula, you will have the exact, you will transform the Bernoulli distribution to this format, so that you can see the Bernoulli distribution is actually a part of the exponential family. So right, so for here you can see that we usually choose ty equals to y. This is something that mainly we don't need to worry about. We just need to see what our choice will be a eta. Actually, just a hint, the most important thing is a eta here. We can further generalize our hypothesis based on this a eta from some property of generalized linear models. Okay, so let's see another example is from the linear regression, just to show that this is also the same case. So for linear regression, we assume the data follows Gaussian distribution. So my understanding of linear regression is like we say that if we are given a sample x and y, and we say that we're trying to find, we say that that y is based on like the Gaussian distribution of x, and we are trying to find the most likely y. So trying to find a theta that can generate the highest probability of y using that distribution. So anyway, for linear regression, the data follows Gaussian distribution, and Gaussian distribution can be written in this formula. It can then be transformed to this, and then we can choose a dot ta tya dot by like this, and then we will also see if you are interested into this, you can replace these parameters and put them into the exponential family I just talked about. You will see that it actually fit. So linear regression is Gaussian distribution also belongs to the exponential family. All right. So right now, just to conclude from a little bit, if you're confused with this expression, that's okay. So the main point is that we have this exponential family. We have several coefficients. The most important coefficient is A eta, and then linear regression and logistic regression are both they're all of them, both of them are in this exponential family. So that the generalized linear model have several properties. So I know it's a bit confusing because I'm still figuring out. I don't know why, but I think originally I have blank lines here, but I don't know why it's not. Okay, so the most important thing is that how we generate our hypothesis. We can generate our hypothesis using the generalized linear model property. So the first important property is that our hypothesis actually comes from the expectation of y given x. And what is the expectation of y given x? Is the derivative of A eta, like here. If we can find the derivative of A eta, we say that's the expectation of y given x. And then that is our hypothesis. And then another thing to notice is that this is not like a mathematical fact. It's more like design choice. But usually we say eta equals to theta t times x in our case, because we express theta in vector w and b. So that could be w, but mainly the idea is the same. So let's see how we finally generalize our hypothesis. So, like I said, our hypothesis of logistic regression should be the expectation of y given x. And expectation of y given x is the derivative of A eta. And then we find out the derivative of A eta, and then I think the derivative is like this. And then we replace eta as theta tx, and therefore we have our hypothesis function. It will be more clear if we see this as a linear regression. So from here, we can say that the hypothesis function of linear regression should be the expectation of y given x. The expectation of y given x is derivative of A eta. Derivative of A eta should be eta. So eta equals to theta tx. So our hypothesis function for linear regression should be theta tx, which is exactly what it is. So that's how we that's how we get our hypothesis function. And then and then after we have our hypothesis function, we can see it from here that the hypothesis function is basically the probability, so that we can have the multiplications of different samples probability. We can take the log, and then we can maximize the log likelihood, and then we can have an update rule. So just to conclude, so actually we don't really say that we just use sigmoid function here. There's a reason behind it. So like for when you see some samples, like you see, I don't know, the like sometimes that you are using the linear regression, and so you know that I need to, because of the property of the example, I need to apply Bernoulli distribution, or I need to apply Gaussian distribution. That is something you decide from the property of your sample or your problem. And then when you know the distribution you're gonna need, you want to use, and then you write down the distribution, the probability of the distribution function. You apply, cleverly choose ty, b, eta, a eta, so that can fit into the exponential family. And then you know what a eta is. You take derivative of a eta, and that's your expectation, which is also your hypothesis. Therefore, you get your hypothesis, and then you use log likelihood maximization to get your update rule. So basically, that's the like the mathematical process behind this. So yeah, I'm wondering if anyone have any issues about it. What?
I think your presentation was impressive.
Okay.
Thank you.
Thank you. Yeah, you can read through that. I'm mainly just I don't do the computation, but basically that's it. You can see it through this these notes. Yeah.
Please just make sure you don't copy sentences from other references. That is considered plagiarism. So please just write them in your own words. Formulas are okay, but sentences should be perfect or like written in your own language.
Okay. Okay. I will change that later.
Yes, and I found that all these are pending proposals, right?
Yeah.
So maybe now we can, everyone in the team, maybe we can vote on her proposal to pass these proposals. So I think you can search for logistic regression and first find that node for everyone in our team. And Javi, maybe you can show to us.
Sorry, let me computers. So I search. So I send the link to this node. Is this?
Logistic regression, I think is that one. Oh, you should choose data science.
Right.
And also, Javin, could you please check all the tags?
Yeah. Okay.
Yeah, I think that is a big problem. Jiang, so in each community we have a pending proposals list. So if you close the search bar, can you close the search bar? You see that pending proposal list. So right now it doesn't have any notifications for you because your tag is computing science. You should change your default tag to data science. Does it make sense? So first of all, find data science. So that's why I was not aware of any of your pending proposals because they are under different tags. They're not under the data science. So you should have everything under data science and you can add other tags. But the main tag for you should be data science. So you should start with, you don't need to choose anything. Just don't choose anything. You see that check mark on top? Just get rid of that. No, the check mark. Yeah, just uncheck that. Why did you close it?
Oh, what do you mean by sorry?
Let's open search, please.
This
and
one.
check, yeah,
Okay, I see.
and search data science. No, you don't need to choose anything. Just search.
Okay.
You don't need to choose anything. Just search data science. Press enter or search button.
Okay, my computer is not responding. Okay.
All right, so that is the data science node. So please just click data science. Okay, so it was open on your map. So please close search, zoom out a little bit. So you see that is, so you need to use, if you're using mouse, you need to use Alt and mouse scroll to zoom slowly. If you're using trackpad, Alt mouse scroll bar. I mean, Alt mouse wheel. If you're using trackpad, you can just zoom in and out using 2 fingers.
Yeah, I'm using 2 fingers.
Okay, sure. So what you need to do is you need to just zoom out a little bit. I want to show you something quickly before we go. Yeah, so just stay here. So you see, map is divided into multiple parts. Like
Right.
you have a cluster on top, they have something in middle. You have like multiple clusters. So if you add nodes under data science tag, all of them would be clustered in the same place. Like
Okay.
the very first tag, like the very top tag on each node determines its cluster in the map view. The reason your proposals go under other clusters and they're scattered is because they don't have data science as their first tag.
Oh, okay, I see.
So in order to change your default tag so that from now on, whatever you propose, it goes under data science, you need to click your user avatar, user profile icon, right? And then, so later on, it will be great if you upload a user profile picture so that we can easily recognize you. So move your mouse to.
I see. Yeah. Oh, yeah, okay.
Move your mouse to the left, very left side. So move your mouse, yeah. So click on the logo. Just stay on the logo, on top.
Top.
Above that, just stay there.
Oh, this
Yeah.
one.
So press, are you using Mac or PC? PC, right? Control minus. Control minus.
Wait.
One more. Good. Okay, so now you see that types of supervised learning. I would try one more control minus. Good. Okay, so this is a better zoom level for your screen. Okay, so now zoom into the data science node on the map.
Do I need to search it or?
You can if you like. If you don't know where it is, just search it.
Okay.
You can close this and search it. Yeah, that's right there. You don't need to do anything. It was there.
Okay.
Just wait. Wait.
Okay.
Oh, you need to get rid of that check mark.
Oh, okay.
Press enter and wait. Yeah, here it is. Okay, just find data science. Yes. So close this, go to your user profile. Change it to data science.
Okay.
Great. Now, from now on, whatever you propose, it would be under data science. And if you zoom out one more time, no, not using control minus. No, not that. So bring your mouse to the sidebar, to the left. Yeah, control plus. Yeah, zoom in more. So this is good. Don't zoom in more. No, zoom out. Yeah, this is good. Okay, so bring your mouse in the middle of the map. So now use 2 fingers to zoom out. Okay, good. Okay, so now if you click that clusters button on the left, so just clicks once. Yeah, so it shows you different clusters. So you have that data science in the middle. Oops.
Oh, okay.
Right.
Yeah.
So you have that data science in the middle. You have CSCW on top. You have like regression something on at the bottom. So you have multiple tags, you have different types of nodes open, And so the first tag, like the tag on top of each of these nodes, determines its cluster. So you can close the clusters. Just click the cluster button again on the sidebar. And close the sidebar. Okay, so zoom in on one of your nodes. Just search one of your nodes, your own nodes. I think they're open on your map. You don't need to search anything. That is data science. So
I'm not sure. My nodes are pending. My nodes in pending. So sometimes
they're not here. They cannot be here because pending list only depends on your community. So right now, your community is data science, but the nodes you propose are not under data science. They're under other tags. That is the problem. You see what I'm saying?
yeah. So I would just search my nodes.
You don't need to do that. Just close this. Just scroll up. All of those nodes are open on your map view. Logistic regression is open here, right? Just move up. So these are your nodes, aren't they? Some of them. That is logistic regression. You passed it, right?
Mm-hmm.
So open the pencil button. So this has 12 upvotes. That's why none of your proposals are accepted. Just click one of your proposals, and you see it goes away. Click one of your proposals.
Actually, my proposal is in regression problem.
I see 2 of your proposals there, but that's fine.
Oh,
Yeah.
okay. Yeah, that's something I proposed earlier. This is my just now proposal, and then I choose one of them.
Sure.
Okay.
So you see it goes away. The reason it goes away is that this is under another cluster right now. So click on the tags button. Now click on the right. Oops. You open your user profile. You see on the right, there is a tags and references, right? So you have 2 tags here, computing science and regression problem. So your first tag, you actually need to delete these and first define data science, and then you can add whatever tag you want. But you need to delete these and define data science on top, right? So, so I feel like it's much easier if you just create these proposals again with your default data science tag.
Okay, I see.
And then, so all of these proposals would be added to the list of pending proposals. Everybody would be able to see them, and we can just review them and accept them.
Okay, sure, I can do that later.
Thank you.
Okay, thank you.
I also saw you had 2 proposals under logistic regression. Later on, please also do the same thing with those proposals.
Okay, okay.
Sorry, if I interrupted. I just wanted to explain like how these proposals work with the default tag.
Okay, thanks, Jiayun and Iman. And Jiayun, I think after you have proposed these notes, everyone in the meeting, if you saw in your pending proposal, Jiayun's new created notes, you can upvote, and then we can pass these proposals to the map.
Yeah.
Okay, so I think that's all of our today's meeting, and I'm looking forward to who would like to present in our meeting next week. So, Aryan, could you please stay with me for some more minutes, and others, you are free to go now.
Thank you.
Okay, bye.
Have a
Thank
good
you.
day.
Thank you. Bye-bye.
Okay, so Aryan, I will send you a link to a Google Doc, so please wait for a minute.
Yeah.
Can you open it?
Just a minute. Did you send it on Teams?
I sent through our chat in Google Meeting.
Oh, okay. I don't know. It doesn't show.
Oh, I will first stop recording. Sorry.